Hi, it's Jack the Science Kid, and today we're going to talk about rockets. We recently did a rocket launch which I'll now show you the footage of.
Hi, this is Jack the Science Kid, and I'm here with a model rocket that I've built. It's, we're going to launch it today, and I'll go back to the lab soon and explain all the forces of flight. But today, let's just enjoy the beauty of this flying. Okay, so I need to put this safety lock in. Okay, the rocket is now armed.
Okay, do the countdown first, Jack?
Okay, 5, 4, 3, 2, 1, lift off! Well, that was a successful flight. It drifted a bit, but we didn't have to run far to catch it.
How far do you think it went?
Only maybe just like 100 meters away from here. 200.
How high in the sky?
200. Just maybe 200 meters. We're pretty high.
It was very exciting, wasn't it?
Yeah. That was my first rocket launch.
And we can launch again.
Yep. I'll see you again in the lab.
Now that we're back from the rocket launch, I'll take you through the science of the rocket. Firstly, this is the rocket that we launched here. As you can see, it's very tall, and this cap comes off, which makes the parachute come out so it can land. We put a rocket motor in there, and then you saw that we had a launcher, and when we pressed the button, it ignited the rocket motor. I'll show you a presentation of rockets that I did. So first we have to answer the question, what is a rocket? A rocket is a projectile that ejects gas or other substances from the back to propel it forwards. There are different kinds of rockets, like a military rocket, for example, a missile, and also fireworks are a rocket because they propel stuff out the back to go forwards. The history of rockets. In the 9th century, the Chinese learned to use gunpowder to make fireworks. They also attached gunpowder tubes to arrows, including the use of bows. They called these fire arrows. And then later, people started using rockets as a military device. But then they realised that they could use rockets to explore outer space and learn more, which was much better than killing people in a war, in my opinion. Now, the physics of rockets. First, all rockets obey Newton's 3 laws. Newton's first law is that the rocket will carry on moving unless acted on by a force, such as air resistance, and it will stop, or it'll stay still unless acted on a force, for example, the rocket's engine. Pretty simple. Second, Newton's second law is a bit of a hard one. It means that it's the force of the rocket engine is equal to the mass of the rocket times the acceleration. So, for example, say you want to find the force needed for a mass of 2 kilograms to accelerate at 7 meters per second squared, which is the unit of an acceleration. Using Newton's second law, the force needed would be 7 times 2, which is 14. So we'd need 14 newtons to move it. Newton's third law is also a simple one like the first law. It means every action has an equal and opposite reaction, which means as gas from the rocket pushes backwards, the rocket goes in the opposite direction with equal force forwards. Chemistry of rockets. The chemistry of rockets means the things it's used to protect it and also propel it through space. In order to get the rocket off the ground, a chemical reaction has to occur between two things: a propellant, which is also called the fuel, and an oxidizer. There are different ways we can combine the fuel and oxidizer to launch the rocket. There are usually 2 ways that we can do it, and the first way is using a liquid-fueled rocket that uses liquid propellants and liquid oxidizers, and solid fuel rocket, which has the propellants and the oxidizer mixed together to make a solid that is ignited. Liquid rocket propellant. Liquid rocket propellant is more desirable because it can be controlled. Its speed. It can control its speed. Like you can throttle it with different valves, and it can be also cut off. A lot of combinations of fuels and oxidizers have been tried and tested. But the most common fuels are kerosene, alcohol, liquid hydrogen. Some common oxidizers include nitric acid, nitrogen tetroxide, liquid oxygen, and liquid fluorine. Also, the Saturn V rocket used kerosene and liquid oxygen. Solid rocket propellant. Solid rocket propellants are different from liquid propellant because of a few things. Instead of being stored as a liquid in separate tanks, the fuel and oxidizer are mixed to make a solid. Usually the fuel and oxidizer are already solids and they're just mixed together. The ignition system is also different. There is a spark generated by an electric current, such as the beeper that I used to ignite my model rocket, and then a chemical reaction between the air and the rocket propellant makes a fuel, creates a chemical reaction and pushes stuff out the back to propel it forward. Now, we created a bicarb soda and vinegar rocket, and it was very successful, and it was pretty fun to play with. Let's see it. Nice. This is the chemical equation for it, which can be quite confusing, so I won't go into deep detail on it. Now, I also included an Apollo 11 Saturn V launch, but I don't think we'll have time for that today, so see you next time.